Welcome to the Actionable Futurist podcast, a show all about the near-term future with practical and actionable advice from a range of global experts to help you stay ahead of the curve. Every episode answers the question, what's the future of? With voices and opinions that need to be heard. Your host is international keynote speaker and actionable futurist Andrew Grill.
Today's guest is Jochen Appel, Global Vice President of Digital Industries at Nokia, leading their endeavours for advancing the digital evolution of the transportation, energy, public safety and defence industry segments. Jochen and his team work with customers to harness the power of networks to support critical operations, intelligently automate processes and proactively manage assets, achieving the benefits of pervasive connectivity and digital transformation. Now, I've just come back from speaking at the Middle East Rail Summit in Abu Dhabi, so I got to see firsthand how technology is transforming transportation and also saw the Nokia stand. The big question at the top of the show, what's the future of rail?
The future of rail for me is really about automation and digitalization. These guys need to get more trains on the track, and you can only achieve this if you automate much more than what they're doing today.
I'm a bit of a geek. A lot of people on the podcast are not familiar with what's actually used today in rail infrastructure. If you're a passenger, you will see these little mini base stations on the side of the railway with directional antennas. That's the existing system. Maybe you could talk about what companies are using today and where we need to get to.
What you see today is basically what is called GSMR, and it's a technology which got introduced 23 years ago. So most of the rail operators in Europe, a lot in Middle East, and the majority of the rail operators in Australia, for instance, in China, they are using this standard. Let's say, since it is a 20 plus years old technology, we are running out of components, we are running out of people who are able to maintain this. So in the future, we need to migrate to a more powerful and new modern way of a communication system.
And this new system is called the Future Rail Mobile Communication System, or FRMCS for short. This is using the latest technology, 5G, faster data speeds. How is it different to GSMR?
It's using 5G, so it's using the most modern wireless system we have in the market right now. And the big benefit is it is standardized 3GPP system. So I think it is a technology which is commonly available. So you have a big ecosystem of not just network vendors, you have a big ecosystem of device manufacturers, and you can put a lot of very advanced use cases on this system because you have much more bandwidth. So you can put video there, you can put voice there, you can put train control there. So there's a big benefit in having a 5G system compared to GSMR, which can do a little bit of train control and a little bit of voice.
So it seems quite limited. I'm just surprised that we haven't upgraded it a lot earlier. What's holding it back? Is it governments or operators? Or what's driving the need to upgrade?
So first of all, it is a common standard across all the European countries, right? And if you need to find a common, let's say, sense of what you're going to do from a technology perspective, there is a long-lasting process involving all the stakeholders. And I think we were lucky that they agreed on GSMR 23 years ago. And of course, there are a lot of trains who need to migrate it, not just the networking piece. So there's a lot of stuff which holds the industry back to migrate, and it's a big commercial effort to do this. However, at a certain point of time, you can't stick to old technology all the time. So at a certain point of time, you need to migrate.
So just for my information, sort of train control and those sort of things, if it's limited on the GSMR system, how are we getting data back from trains today if they're not using this future mode of operation?
So we are getting data back from trains today, but it's very much along the standard of ERTMS, which is the train control system, which we are using in Europe and in those countries who are adopted this standard. And GSMR is part of this. But this data is limited to train control. So you can steer trains. You can tell the train what's ahead of them, how fast they can go, if they need to slow down, all these kind of things. That's all good, and this works perfectly well. So we have a lot of countries adopted this model. However, if you want to move, for instance, in automated train operations even without a driver, then you need, for instance, video traffic, because in the operations center, you need basically a video understanding, okay, what's going on site. And then you have the limits of a GSM-based system, which has a very, very constrained data channel, right? The data channel is good for train control, but it's not there for any advanced data.
So that's a good point. As we move to automated vehicles around the world, whether it be train, truck, road, rail, you're going to need a fast data bearer, and 5G does that. Also, there's low latency, so it seems obvious that it should be upgraded. So what are the unique benefits of the Nokia system that can actually help train operators move to this next mode of operation?
So what you can get from Nokia is basically everything. You can get the infrastructure on the mobile side, but you need also the backhauling. You need basically the services, you need the mission critical push to talk, you need the video services up to a CAP radio, up to an onboard gateway. Although we are not producing our own onboard gateways, we are working together, for instance, with Alstom, so let's say a signaling vendor, to make sure that their system works perfectly with our system. And last year at InnoTrans, the big rail fair we had in Berlin, we were even demonstrating this.
Now, it's interesting that the GSM-R system, R for rail, is based on the GSM global system for mobiles, which, as many know, took a long time to get all these countries to agree to standards and frequencies and those sort of things. Would FRMCS become a global standard, just as mobile platforms and GSM has become that global mobile standard?
So the bigger vision of FRMCS, as it is, of course, predominantly standardized for European countries, there is a big potential that this gets adopted by railways across the globe, because it's open for any frequency, it's open basically for any bearer, it's very much not tied to any specific regulation. So I think that is really something which helps everybody to use or to take benefit of a big ecosystem which will build up just because maybe Europe is adopting this. It is also a big benefit for other countries that they can rely on these ecosystems. So yes, because it relies on standards which are already available across the globe, it has a good potential to become a global rail standard.
And so who was responsible for developing FRMCS a few years ago? Was that Nokia? Was that an industry-wide initiative?
No, it's basically an initiative driven by the UIC, so by the Rail Community of Europe. They basically understood, because the rail communication vendor industry, so Unify, basically, we told them, look, we can maintain GSMR until 2030, roughly, right? And there, of course, there are debates right and left, but at that point, I think it was an initiative coming from the industry, from the communication industry, motivating the rail industry. Said, okay, you need to think about a new standard. It will take many years, and the learning is it took already many years, and we know that it will still take 2-3 years further down the road until we see first real commercial deployments based on these standards. It's a joint effort between the operators and the industry to drive this.
IDC, a global research company, recently surveyed railway executives about the future of rail. What were some of the survey's key findings?
For me, a key finding was that although we haven't had that much insight, maybe, we saw that, of course, 80% of our customers, or basically the rail operators which got surveyed, they already started on the FRMCS side. It's a very good start. And we were also amazed about the amount of operators doing this already. Another finding was also that the complexity they have today and the big TCO they face today with all these purpose-made communication systems they are operating, and then the big promise that with FRMCS it can be produced based on standardized hardware everywhere the same in the world, that's a big benefit for them. So I think this is really something they look forward, and this is the main outcomes for me.
Now, in rail systems, it's literally lots of large moving parts, and safety is critical both for the people operating the rail network as well as people using it. So what are the safety improvements that FRMCS brings over GSMR, and what are some other improvements that the FRMCS system can bring?
From a safety perspective, GSMR does what it is supposed to do. The big benefits from a safety perspective, when we think about more automation, then we need to give systems steering basically everything a good view of the, let's say, environment the train is in. So I think we are providing more data, and therefore the system gets more safe. They get better situational awareness. They understand, is there any obstacle on the track, and so on and so forth. So we can simply provide much more data, which will help automated systems to react much faster and in a much better way. So train operator will get basically a high level of efficiency gain when they migrate to FRMCS, because again, they can collect more data about the situation of the track. They can do much better proactive maintenance. So you will see a higher availability of the rail infrastructure, but you will also understand, or you will also see that rail operators are able to bring much more trains on the same track because they can run much closer because of the latency improvement we have in the network.
Well, that seems like a key benefit, because if you want to run trains more often, here where I live in London, the Elizabeth line, the new rail network, they're now operating at what is probably the maximum capacity, and that is down to the signalling system. And obviously they've got next generation signalling systems there as well. But I didn't really realise that in order to be able to run trains more regularly, it's a safety issue, it's a scheduling issue, and those sort of things. So it sounds like this has got huge benefits for network operators, not just in the maintenance, and they can probably do more predictive maintenance, and therefore the trains won't wear out as often. They can replace the parts. 5G has some real benefits as a technology. There's network slicing. You can run private 5G networks. What are the specific 5G components that will be integrated into this rail network that are already being used in consumer and broad 5G networks?
The specifics on 5G is basically on one hand is you can deal with more spectrum option. You have much more bandwidth. If you have spectrum which goes up, let's say on the upper side of this spectrum family, and you have the possibility to connect millions of sensors and devices just in one cell, right? And this is the big promise coming out of IoT. And again, this goes back to, okay, the sensors which are today in a train, which are connected probably via whatever network, that's okay. You can aggregate data. You need to be very selective on the data which you can transmit from the train to the operations center. With 5G, you can transmit any data, because especially when we talk about machine learning or predictive maintenance, you don't know which data you need to be able to do predictive maintenance. You need to collect all the data, and then you understand, okay, which data are very let's say beneficial and which data you can scrap, right? And this is, I think, the big benefit, that the limitation we have today with the existing systems in terms of bandwidth and how many devices you can connect per cell, they go away with 5G. And then you have basically a big variety of use cases you can realize, because there's no limitation on the bandwidth side anymore.
So there's probably two things there. At the moment, the data can be collected. I'm sure brand new rolling stock, there are a multitude of sensors on that, but I assume at the moment it's probably not able to send all that data back in real time. I'm wondering if it's being collected and then maybe downloaded to the depot versus being able to have that in real time. And the parallel I like to hear is, I know that Airbus have instrumented every part of their airplanes, and I understand that after a flight, a terabyte of data gets downloaded so they can actually look at the health of the aircraft. And I know from my experience with Qantas, they have network operations centers. They know the health of the plane while it's in flight. So what you're saying is this new generation technology really does allow more real-time decision making, and maybe they'll find out information about the rolling stock they never knew that they could, because it's happening in real time. And if a particular bend is always stressing the vehicle, you're going to know more about that earlier because you've got trains going through. So maybe talk through some of the use cases that will be unlocked with this new data availability.
We are in constant discussion we are partnering with most of the rolling stock vendors as well, because they are usually also signaling vendors. So they are our partners in the various go-to markets with various projects. So the benefit is not just that you can collect the data. Indeed, you can do this in the depot, and they are doing this today. The automation behind in terms of mitigating issues. So for instance, if you would collect the data in what we call real time, so let's say a door gets broken and you get an instant notification the door is broken, then at the next stop, and we think more in a mainline environment, right? In a metro environment, this doesn't make sense, but in a mainline environment, at the next stop, there is already a technician who is able to repair probably this door if he knows what went wrong, what is probably broken, having already the right spare part with him, and so on and so forth. So you can really collect data, you can give it to a machine, the machine is analyzing it and triggers already the corrective action, which probably in this use case is we send a technician. This is just one use case. Another use case might be video, which usually consumes a lot of bandwidth, but also requires a low latency connectivity. So in an AT03 or 4 environment where you don't have a train driver, where you even in an AT04 environment where you don't have a steward or something at the train, and the train stops in the middle of nowhere and you need to probably evacuate the train, then you better know what is the environment, right? Probably the train stopped in the middle of flooding or something like this, so you don't want to evacuate people there. So this all is possible with, let's say, with these higher bandwidth. And of course, certain use cases can be done through a usual carrier network of a mobile network operator as well. And this is the next benefit of using a harmonized system, because you can use this as a backup. So if your bandwidth is in a certain area not enough, or you need for a specific occasion, you need more, then you just do basically a rooming with the mobile operator, and then you have more bandwidth on demand. And this is the big benefit of using a modern 5G system.
So I'm sure the people that have decided they're going to make the move to this new FRMCS, it's not a simple rip and replace, because you've got existing rolling stock, you've got safety considerations. So what are the transition plans to adopt these new FRMCS systems, and can they be run in parallel with the existing systems?
An infrastructure manager of a rail operator tells you what he thinks or she thinks is all concerned about this move. You might run away, right? Because this is horrible complex, right? It is really horrible complex, because and it's not just removing or building up a new network. As you said, there is a lot of, let's say, rolling stock involved. There are a lot of government entities, regulators involved who need to give their stamp, and this is safety proof. You have the signaling companies on top, and so on and so forth. It will be a phased approach, and it is a phased approach, and we are doing a couple of trials already with some of the major rail operators. It will be that you need to deploy an FRMCS network next to a GSM-R network, because you need to give at least 4 or 5 years to the train operating companies to move from one technology to another. They can't do this just in 1 year or something like this. And again, on the, let's say, continental Europe topic is that a train runs from Portugal to Helsinki, right? So, and you need to make sure that the same train operating company can run in any of these networks. There's a parallel operations of GSM-R and FRMCS needed. And this is probably another advantage of a company like Nokia doing GSM-R and doing FRMCS in the future as well. There's a lot of interworking needed between, on the functional level, between GSM-R and FRMCS. So you can't ask the train driver to know if he operates in an FRMCS environment or in a GSM-R environment if he needs to press the emergency button, right? It's just a button, and then everything needs to go very smooth, irrespectively in which network he is connected. We will see an introduction of FRMCS. It will be up and running, maybe line by line or certain corridors. And then we will see, after every train operating company had enough time to change the onboard equipment, then we will see a shutdown. So we expect a transition phase between 4 and 7 years, depending on the let's say size of the network and where it is located. Is it more centrally located so that you need to connect a lot of other countries? Then it might take even longer.
So you mentioned you've got some existing trials happening. Anything that has pleasantly surprised you, some things you didn't expect that you're seeing some increased benefits from the trials you're running already?
We do trials predominantly with our customers, but also with SNCF, with SBB, with Deutsche Bahn. Deutsche Bahn is relatively advanced since they were able to isolate a complete piece of their network, which is not in commercial operation. We're doing some learnings, especially on sometimes very basic things. So is the frequency to be used, is it interfering with others? Yes or no? What is the size of the cell at the end? Today we are running in a complete different level of frequency with GSM-R than later with FRMCS. We were expecting that we probably need double size of the cell. The reality is, depending on the use case, you might not need really let's say the double amount of the cells at the end of the day. So these kind of things are important. We also see some functional outcomes when it comes also to interworking between GSM-R and FRMCS. That's, I would say, a little bit of way to go to get this completely up and running and aligned. And there's a particular focus on the standardization at the moment.
So what should smart rail operators be doing now to prepare for this future of rail?
do trials, make your own learning, right? It is very important because every country, unfortunately, has its own spectrum regulation. So maybe the spectrum, which is now getting allocated in the country for FRMCS, was used 10 years before for something different. You still have a bunch of equipment out there radiating in this spectrum. So you need to understand, is there a relatively high level of interference in your country? We know that every rail operator has implemented GSM-R and on the functional level in different ways. So some are using this for instance, for shunting functions, some are using this for the stewards in the train, and so on and so forth. So they need to understand what is the real impact changing my specific system to a new technology, and what else do I need to do on top of what is in the standard. So we only recommend, okay, go and try to build up, say, a trial environment which is very close to your GSMR based operations you have today.
What does a really forward-thinking rail operator look like? What are the traits of an organisation that says, okay, I know this is going to be expensive, I know it's going to take 4 to 7 years, but I really want to be known as a rail network of the future. And when I look at what's happening in the Middle East, Etihad Rail is fortunate they actually have a brand new network that they've got to deploy and play with. So give me a sense of what does a really forward-thinking transportation operator look like? What are their traits? And obviously they're the sort of companies you'd love to deal with because they want to buy this system now.
The forward-looking people are usually thinking, okay, it's not just a replacement GSMR to FRMCS. They think in the possibilities they might get even just in 10 years from now because of a new system, and then they design it accordingly, which is, yeah, maybe even the spectrum I can get today is not enough. Okay, in 10 years from now, I might get additional possibility on the spectrum side. I can implement much more stuff. So I think the ones who are really thinking in digitalization almost in everything and in doing automation almost in everything, they are the forward runners in terms of, okay, I anyway need a network, right? So I anyway need a superior network doing this. I implement it today. Once developers got the App Store platform from Apple, you saw the amount of apps exploding. And this is what we think will happen there as well. Of course, train control, mission critical voice, and all ATO type of stuff, that will be there anyway. It's already there today. It will be there anyway. It will be there in the future. And it might be, let's say, it will run probably even smoother. But the amount of use cases you can put on top, which will really help to improve your train operation, I would say the sexy thing to think about, yeah.
As this is the Actionable Futures podcast, what 3 actionable things should our audience do today when it comes to better understanding the needs of modern transportation networks?
They need to be customer friendly, right? And customers are people who get moved from A to B, but also companies who put goods on the rail network. So, of course, let's say as a user of the transportation system, you want to have, let's say, a superior service, always in time, maybe even no timetable, like in Copenhagen, right? You don't have even a timetable. You can stay there in 2 minutes, a train is coming and you can jump on it, right? And this is what people want. This is the same experience like jumping in my own car. It always stands in front of my door, so I can go there. And if the rail system provides a kind of similar service, it's something which really gets used by the people. Then on the cargo side, if a rail system can provide a similar service or a better service, say, or much less carbon footprint, then people will use it, right? So the attractiveness of the service needs to be there because the rail system as such is anyway seen as the better way of moving things and people because it's more green. So from that perspective, that's really the key topics for a modern transportation system, yeah.
I've just come from a conference in London called Innovation Zero, which is talking all about the move to net zero and ESG initiatives. And they're all talking about electric vehicles, but we already have electric trains that are very, very sustainable and they reduce emissions. So I think people should look towards rail as part of the future as well. Fascinating discussion, Jochen. Where can people find out more about you and your work?
My LinkedIn profile is always up there, and people can send me an email, can basically call me. I'm very approachable, so I'm happy to answer to anything.
Well, I think you've answered the question, what is the future of rail? I think you're right in the middle of it, and I'm glad to see that companies like Nokia are looking towards the future of rail. Thank you so much for your time.
Thank you, Andrew.
Thank you for listening to the Actionable Futurist podcast. You can find all of our previous shows at actionablefuturist.com. And if you like what you've heard on the show, please consider subscribing via your favourite podcast app. so you never miss an episode. You can find out more about Andrew and how he helps corporates navigate a disruptive digital world with keynote speeches and C-suite workshops delivered in person or virtually at actionablefuturist.com. Until next time, this has been the Actionable Futurist Podcast.